Okay, now let's do some problems related to radioactivity, grade 12 biology. These questions are related with fossil dating and the part that talks about evidence of evolution, particularly the paleontologic part, fossil dating. Question number one. If 8 grams of carbon-14 is found in a fossil and 16 grams in living organisms, how old is the fossil? The question. Just compare these two numbers. The amount of the radioactive carbon-14 in living organisms and its amount in the fossil. Its amount in the fossil is 8 grams. Its amount in the living organism is 16 grams. Therefore, the fossil has lost 50% of the carbon in living systems, its original amount, 50%. Therefore, what is the time period in which the radioactive substance loses its 50% of its radioactive substance? That is one half-life. That is 5,700 years old. This is very simple. And if you do it, just 16 gram carbon-14 in living organisms, but for carbon-14 in the fossil is 8 gram. The difference is 50% loss. The 50% of it has undergone decay. It does this in one half-life. That is, it is carbon-14, 5,700 years. Thus, the age of the fossil is 5,700 years. Let's go to the second question. Question number 2. The ratio of the amount of remaining carbon-14 in a fossil to the original amount is 1 to 16. You see the ratio. The ratio of carbon-14 in a fossil to the amount of carbon-14 in the original. Sample original, that means you can take it in the living sample. 16, 1 to 16. What is the age of the fossil? You can do in a similar fashion, you can do this similarly, just if you consider x is the original amount there with one half-life, that is 5,700 years, it becomes x over 2 half. In another additional 5,700 years, x over 4, half of x over 2 is x over 4. And in another 5,700 years, x over 8. In additional one half life, x over 16. Compare this. The ratio of x and x over 16 is 1 to 6, which means if the ratio of carbon-14 is 1 to 16 in the original carbon-14 and the amount in the fossil and the original is 1 to 16. This means it has undergone 4 half-life. Count the half-life. 1, 2, 3, 4. 4 half-life have elapsed. Therefore, 4 times 5,700, that is 22,800 years, is the age of this fossil. It's very simple. The third question, a sample of wood found in ancient tomb contains 25% of its original carbon-14. What is the approximate age of this wood? It contains 25%. It's very simple. When radioactive substance is lost, half is lost each time. Therefore, from 100% to 50% after one half-life. From 50%, half of 50 is 25, to 25% after one half-life. Therefore, it is a matter of 2 half-lives, the age of. Therefore, here 25% of carbon-14 remains, means it has undergone decay twice, from 100 to 50, from 50 to 25. Thus, 2 times 5,700 means that is 11,400 years is the age of the wood. Question number 4. After 11,400 years, how much carbon-14 would remain in a fossil? Another way of asking, of course, 11,400 years, how much carbon-14? You just calculate, divide 11,400 by the half-life of carbon. that is 5,700. You get two half-lives. Two half-lives. This means from 100 to 50, from 50 to 25. Therefore, 25% remains. You can either go just like this. 11,400 means it has undergone decay twice. 2 times 5,700 means 11,400. Thus, if it decays 2 times from 100 to 50%, from 50 to 25%, therefore 25% of the carbon-14 remains. And the last, but by no means the least, what is the approximate age of an igneous rock that contains only 1/4 of its original potassium? 1/4, imagine, from X to half X, from half X to 1/4X. You see? How many half-lives? 2 half-lives. It is potassium. Twice of the half-life, twice of 1.3 billion years. The solution is just like this. If 1/4 of potassium-40 remains in the rock, the original potassium-40 has undergone decay twice. Thus, its age is 2 times 1.3 billion years, which is 2.6 billion years. And the answer. Please try to do similar questions. And your exam may include calculation. Of course, it's very simple. Thank you very much. See you.